All right. Well, good morning, everybody. My name is Cale Harbor. I am the product manager here at Advanced Control Solutions. Wanted to thank you for joining us this morning. I've got a lot of information to share. A lot of it is exciting. So I have asked our regional manager, Mr. Casey Fortenberry of Epson Robots, with us this morning. And we're very privileged also to have on the line with us Mr. Michael Ferrara, who's the leader of Epson Robots USA. So thank you, gentlemen, for joining me this morning.
My pleasure.
Yeah. So rather than just a real strict PowerPoint presentation reading off every bullet point, this morning's going to be a little conversational. I've had the privilege of working with Epson Robots a good number of years, and sometimes I drive Casey and Michael crazy wanting the robots to do things they've never done before, but they generally work out okay. Casey's got a good number of years with robotics and Epson already, and so is Michael. Casey, you want to introduce yourself first to everybody?
Yeah, absolutely. Good morning, everyone. My name is Casey Fortenberry. I have my camera on so you guys could actually see me. I'm in my home office here, as we all are, I would assume. Been with Epson for almost 3 years, not quite, coming up on that in a couple of months. I live in Charleston, South Carolina, so I'm right by the Georgia area, and you can catch me in Marietta at least once a month, every other month, something like that. So hopefully I've met you guys that are on the line. If not, definitely feel free to reach out to me and Kel, and we'll do whatever we can to help you as you go forward with your projects.
Yeah. Now, Michael, I know you weren't expecting to present this morning, but could you do a quick bio of yourself for everybody? I think you're Michael, mute. You're muted.
Good morning, everyone. I'm Michael Ferrara. I'm the director of Epson Robots. I've been with Epson for a few years, like 28, so quite a while. I'm responsible for all sales and support that goes on in all of the Americas. So whether it be Georgia or whether it be Brazil, they tell me it all comes up to me at some point. So that's what I do. It's great to see you guys this morning and hear Cale and Casey present some new products that we've got coming down the road. I've been with Epson for a long time, always involved in robotics. So that's me.
Good deal. Thank you, Michael. I tell you, it is kind of amazing some of the updates that we've got this morning, just the sheer fact of how many new products that there are. We've had quite a few that has become available. We've got 4 new things to talk about this morning. So normally we don't have that many new products at one time. Sounds like things are moving quite aggressively at Epson right now, Casey.
It is. It is. I think this is a perfect time to sort of let everyone into our world to see what we have in the pipeline, what's coming out. And these are real products. You can actually see this. This is not, hey, this will be out in a year or 2 years, or we're thinking about this. This is, you can order these products right now. And we want to make this very non-traditional. So if you have questions, please let us know. We would love to interject. But right now, we want to show you exactly what we work on. And I think you'll be excited.
All right. Well, let's get into it. Quick reminder for everyone. I know that, you know, Epson, the name Epson has been around for a while in the robotics world. It's the largest manufacturer of SCARA robots in the world. And years ago, it was under the Seiko name. So there's quite a history that ties back there. And I think one of the things that get lost is just really the breadth of product offering that Epson does offer, not just within the SCARA world with multiple series for different jobs, but you've got a 30-year history in the 6-axis world as well. What's the total number of combinations of different robots we can get, Casey?
Well, the beauty of this is you're talking about over 400 different models. I know some guys are, you know, breaking into the SCARA market, or some guys might be breaking into the 6-axis market. But when you talk about Epson, you have a full breadth, a full portfolio of a lot of different robots and a lot of different rates. If you want superior performance, if you want low cost, if you want that mid-tier, we have all these different product lines that we can offer you. You know, you may want IP67, ESD, or UL, or whatever the case may be. That's the beauty of Epson, over 400 different models to choose from, so we can pick the right robot for your application.
Yeah. And one of the things I think that also gets overlooked is that Epson makes a great quality Cartesian-based robot, as well as the linear modules for the 7th axis to be able to extend the reach of your SCARAs and your 6-axis robots in those applications that require it.
Absolutely. As we get into the C12, this is going to be important, and you'll find it. I don't even want to spoil it. You'll find it.
All right, well, let's keep moving. Since one of the major updates that we're talking about this morning is the new C12, and we'll get to that in just a second. Just to touch base on that 30-year history that you've got with the 6-axis, beginning in the late 80s and then building on with it. There's been multiple innovations. I know during my time working with Epson since beginning in '06, I've seen a lot of technologies, and we're going to speak about one here shortly, the QMEMS that have been able to be incorporated into more of the robots. I remember when the C3, the first compact, came out, and then pretty soon afterwards got upgraded to the C4. Same basic robot, same motor, same size and dimensions, but with that addition of that QMEM and that better control, the payload was able to go up by a kilogram and the speeds were able to increase. And I think that technology is one of the things that sets Epson apart. And we're going to get into what that is in just a minute, but that's one of those things to really keep up with. Also, the innovations of the folding arm, the N series, has been great for those compact environments to be able to put the robots in. But now today we've got the new one. We got the big boy to talk about, the heavy payload, the C12. This is a new payload range for the 6-axis for Epson, isn't it, Casey?
It is. It is. So now we're trying to get into higher level, more end of line packaging, and that's important. I mean, when people think of Epson, they think of SCARA, they think of smaller 6-axis robots. So to do that assembly work, that small pick and place type of activity. But as you know, as you get done with that assembly, it has to go into some type of package, and that package has to get put on a pallet. So as you look at all of that, we want to start to move into owning that entire line, not just that process, but the entire line. And so with the C12, you see introduction to get into end of line automation.
All right. Well, just real quick, some of the basics. It is a 12 kg payload. It is a 1400 millimeter reach. It does use that QMEM. There it is. We're about to get into it. But you've also got it available as a clean room and an ESD model. Are you seeing lots of demand for the clean room environment for this size arm?
So because it's a new product, I would say time will tell, but we can say with our C8 and with our C4, the clean room, the ESD is something that a lot of customers tend to go after, especially when you get into medical, pharma, or places like that, where you have to really be on guard. You need to watch the particles, and you need to make sure it's a clean environment, and you need to make sure that, you don't damage the equipment. In the event that you're doing, medical and you want to have ESD models available just to make sure you don't have that static discharge that could damage the product that you're handling. So I would say on the C12, we expect the demand to be high, but we've seen it for some of our lower payload 6-axis. So we only anticipate that it'll be there for the C12 as well.
Okay, real good. Well, without further ado, I did want to be able to show what the robot looks like actually moving around. So this is the C12XL. It is a 1400 millimeter reach. It is a SlimLine design. One of the things that I've noticed with my customers in the C4 and the C8 series is that SlimLine design really allows you to fit in a very tight space, a very tight environment. But one of the unique things that I liked about the way Epson designed the base for this is that it allows the robot to get very close to its own base. So that if you're in that tight environment, you need to load that pallet, you can get it up close and be able to reach it, and you still have the motion to be able to move towards it. Casey, do you find that having this SlimLine design, this ability to have that broader reach towards the base of the robot, helps deploy this in applications that more traditional design 6-axis robots aren't able to do?
It does, because when you look at traditional robots, when you get into that 12, 20 kilogram space, the base is a lot heavier, a lot bigger, a lot bulkier, which means you're limited in your movement. You won't be able to sit back and reach underneath itself if it needs to. And if you are confined in movement, you can't get that or take advantage of the full 1400 millimeter reach that you have. So because of this design, I think people will be pleasantly surprised at the actual movement that it has. And this video shows that this is a real product. It is out. We don't say, hey, it's going to be out within a month, 6 months, a year. This is out right now. We just released it this month. After we vetted and tested it, it is ready to roll.
Yeah. Hey, Michael, I'm going to put you on the spot for a minute. I know that with Epson, large corporation, we know about printers and projectors and the other things that Epson gets involved in, but also the Seiko watches. I know that over the years, Epson typically will deploy robots in their own factories first so that we don't get beta versions in the field. The bugs have already been tested and worked out on your own manufacturing lines. Can you speak a little bit on how Epson goes through the vetting process when new products come to market?
Yeah, when new products come to market, we do use them on our lines as well as do a tremendous amount of testing, even testing that goes on here. After Japan has released and said it's all go, we will further test it and test a certain number of products that are incoming to make sure that we feel comfortable that for it to go out into the Americas. So sometimes you'll see, and I get pressure on this quite a bit, you'll see a press release come out of Japan that says, the product's ready to go. And then we got people knocking on the door and I'm going, no, it's not ready yet. Right, we're not releasing it yet in the US, only because we haven't gone through the complete vetting process that we wanted to go through on this end. So by the time it goes out, we're pretty darn comfortable that it's going to do what we say it's going to do.
Yeah. And I've actually got a testimonial that can speak to that. One of my customers that I began working with when the G6 series robot first launched, they actually bought the first G6 robot sold in North America. So some people get kind of scared of buying the first one of anything that comes to market. Are there going to be bugs or problems? It began running production at a contact lens manufacturer in October of 2007 and has been running 2 shifts a day, 6 days a week ever since, and is still in production today. And that was the first of the G6s that was sold in North America. So I can vouch for the fact that when a product gets released in the Americas, it's ready to go and the testing's been done for it. All right, a little bit to what Casey was speaking about. Being able to work with the small to medium robot world, being able to work with a series of SCARAs and 6-axis down a production line. Now we have that robot that we're able to put at the end of line for the larger palletizing, the larger reach, the larger tray handling type scenarios. And one of the things I do want to point out with is this, all of the robot platforms that Epson offers at over 400 different models, they all run off the same software, the same programming environments. There's only one environment to learn to be able to interact with all of these various arms. Right, Casey?
Absolutely. And I think this is very important, especially during times like now where we know people are working from home. And as they get ready to possibly go back to their facility, you have one environment, built-in simulator, and we'll talk about that more in detail. But with that one environment, you can start working on your programming, you can start doing the troubleshoot, you can look at the cycle times. And so by the time you're actually ready to get in front of the robot and download that program into the robot to get it to run, you are 85, 90% there. And I think that's the beauty of our software. One environment, and it programs all of our entire robotic line. Good
deal. Well, here's the highlight of where we're at today. So the C4, been out for a number of years. The C8 was 3 or 4 years ago. And now we have the C12 to be able to extend the line. So within that same SlimLine compact design, with the same programming environment, same software, same controller, we now have a new higher payload. We have a farther reach and we have more capability to go from the small down the line multi-stage all the way to the end where we're handling the full trays coming off of it. So this is impressive to have this breadth of product all within the same similar category. A couple of the new things to point out, that Quartz QMEM technology, and I promise I keep teasing everybody this. The very next slide we're going to go over this in detail. But that QMEM, to be able to add for the better motion control, is really a game changer. It allows for a reduced cycle time. It allows for better payload. But I also noticed with this robot that y'all were able to increase the wattage of the motors going out to the wrist. So joints 4, 5, and 6, we have more power than what we've had before. We still kept the SlimLine design, but a robot of this size with this payload and range to be only a 65 kg arm in its total weight is kind of impressive to pack that much performance in that small of a package.
Absolutely.
And then we've already talked about the ISO 4 clean room and the fact that it's compatible with all the controllers. I think one of the things that we really want to spend a couple minutes talking about is this QMEM technology. And the way I remember being trained on this was the QMM is a quartz crystal that is able to pick up the motion patterns of the robot so that you can make more corrections at a smaller level as the robot begins to move, rather than large corrections right at the end of the move to make sure that the robot is going to position and speed accurately and correctly. And this is something that's been around now about 5-6 years, isn't it, Michael? Oh, sorry, Michael, you're muted.
Actually, a little bit longer than that, Cale. It actually came out, began with the LS series, going way back in the SCARA is where we first put in the QMEMS technology. But it's like correcting at the shoulder versus correcting at the end of the arm.
Right.
Right. Or I'm sorry, correcting at the end of the arm versus correcting at the shoulder.
Okay, that makes sense.
Yeah. So it's much quicker. You know, you can talk about how long it takes to get to, you know, really get to that point in space. But if you've got a lot of settling time before you settle down and get there, then that, of course, adds to the cycle time because you've got to get to that spot. QMEMS takes care of that. So you're settling, you dampen out right away so that you don't have that settling time. So it's really done a lot for us.
Yeah,
so
and that's pretty much what this slide shows, that instead of the red line, which is the more traditional control of a robot where you begin its motion, you're constantly monitoring its position and making correction moves to hit on target. The blue line with that QMEM feedback into it allows you to make much smaller corrections, which the way I remember it described, and Casey, correct me if I get this wrong, when you look at the power available in the joints, you have to reserve a certain amount of that power to handle the positional correctness. If you have better control, you can release more of that power from that safety side of things over to actual increased payload and increased speeds because you don't need as much overhead to compensate. Did I describe that correctly?
That's pretty close. And one of the things I would say, and I think to make this very, very practical, if everybody here is used to robotics and they've used any other robot manufacturer, you'll notice as soon as you get done with their movement, your robot will need a half a second just to settle and get in the right position to do that assembly work or that place work in order to pick in place. You don't have that here. And I think that's what we're trying to drive home, because we can stop that vibration, which means we can speed up your cycle time. That's probably the most practical way we can show this. I mean, because we can throw numbers out and say this is quicker than that, or they're quicker than us, or whatever the case may be. But at the end of the day, when you get to your spot and you need to pick in place or you need to do that assembly work, we can get there faster. We can do it. Our entire cycle time in that process is a lot quicker than other ones, because with QMEMS, you don't have that vibration. We're able to eliminate that.
Awesome. Awesome. All right. So as we move on, let's talk a little bit about the size of it. So I mentioned earlier that the C12XL, the entire robot only weighs 65 kilograms, as compared to other robots out there that might be double that weight. What sort of advantage does this give to the machine builder, the integrator, the designer, the equipment, Casey?
This saves you on your overall cost, right? Because if you have a larger robot that you have at the end of the line that's moving, or that you need to throw on the 7th axis in order to move around, you know, you have to upsize your frames, your bearings, your floorings, and everything, because you have to accommodate for that weight that you have. So having something that's half the size can allow you to save costs as you put that entire cell together. And that's what we're talking about at the end of the day. You can have that same reach, you can have that quicker speed, and you don't have to spend more money just to make sure you have a bigger frame to accommodate that weight and that mass that comes along with that movement, that force that comes along with that. You can accommodate that.
Right. And I'd also think it would help out when we go to put this on the 7th axis. With the RC 700 controller that we have, we can control up to 4 robots off the one controller. So by tying in that 7th axis, putting this robot on top of it to extend its range of motion, everything's programmed from the same environment. It's the same interface. It's the same commands, it's the same software structure. So this allows that adaptability to extend its range and its motion.
Absolutely.
All right. One of the other things that I saw in getting ready for today's discussion was the fact that we will have the ISO 4 cleanroom version. It also makes it ESD for electrostatic discharge to be able to open up into medical, electronics, things that are sensitive to electrostatic discharge. And you've got the vacuum port built into it to be able to draw those particulates away. So I really liked that advantage to it. But one of the things that really caught my attention was this one. I had the privilege to attend the Epson Vision class in California, and as well as the programming class. And one of the things that always came back was when you go to do a mobile mounted camera, you've got cable management to worry about. So you've got to be able to route that either USB cable or Ethernet cable back. Now you've got an RJ45 Cat5 built into joint 5 of the arm. So instead of having to go all the way back to the base, you're able to plug a giggy camera that's going to be either on joint 5 or joint 6 right into it, and it'll reduces the cable management that has to go back.
Absolutely. It's a cleaner look for a lot of guys, as you mentioned. You're not doing that cable routing. Now, routing within the pneumatic lines is something that we've done with a lot of product lines, but we're happy to see it extend into, like you said, the Cat5 cable and the decel pin. So now you don't have these cables wrapping around your robots at the end of the day. Everything is routed in there. It's a very much cleaner look. And also more holes to actually mount your end arm tooling as well. So this is nice. And as we get on some other products that we've redesigned, you'll see where we're going and how this will help you moving forward as you prepare for your tooling on top of your robots.
So if, for example, if I have a piece of end of arm tooling that had 2 pneumatic grippers, I could then be able to come up to the hard points that are on joint 5 to be able to bolt a small valve stack, feed my pneumatic lines. I can feed my electrical pass-throughs right to the 15 pin. I can feed my camera right to the Cat5 RJ45 plug at the end. And one of the things that's not shown, it is mentioned the cable for COM. If I also add on the option for the load cell for the force feedback option that Epson has, that plugs right into the arm as well. So now I could do force feedback, vision, pneumatic, and electrical pass-through for all of my sensors on my grippers, all within the unit without having to have any other ducting hose or cable management, and everything's already pre-routed through.
Yes, very clean look.
Very clean. All right. So this I thought was really unique as well as I was getting ready for this. You're now offering different options as far as the cable management at the base. So rather than just the pass-throughs that go through the arm, you're now offering a cable downward option to go down through a tabletop rather than just off the back. What does this mean for the machine builder, Casey?
This basically means you can have the cabling whichever way you desire, right? We don't force you in one particular way or the other. I mean, traditionally in other robots we have, it's that backwards approach that you will see right there. But if you want it downward, you have it. And also it will help with your mounting, right? You may say, hey, for this particular style, I need to ceiling mount this, or I need to mount it on a wall. You know, it doesn't necessarily have to be tabletop style. So we give you that option. And with the different cable options, you can run that cable which way you want to. So that's pretty new for us, but a very good thing nonetheless.
It also looks like it would clean up the top of your fixture so that if you have other things in the area, rather than having to leave room for those cables coming off the back, with them coming out from underneath, you've got more work surface to be able to use in your design.
Yeah, you can work back there.
Yep, absolutely. All right, the RC Plus software. This is a powerful package. I've had the privilege to work with this for a number of years, and one of the things that I really like about this is the fact that all of the robots are in the same software environment. I have used this many times with the 3D simulator that you can see on the screen, and I think it's really unique. And I don't know of any other company that does this, that offers a full 3D simulator to be able to take advantage of for cycle time studies, for capability studies, for reach. And we have customers on a very regular basis will reach out to me to give me the specifications. I'm doing a pick and place routine. Here are my distances, here are my payloads. And I'm actually able to do a feasibility cycle time study right from the simulation software. And the thing I like about that is if I wanted to verify, can I use a C12 in this? Do I need a C8? What's the time difference? What's the cycle time difference? I can take the same program and drop it from one to the next within the simulator. It's going to run because it all uses the same command and same structure.
Yeah, so a couple of quick things to note. I mean, you will need version 7.47, which is the latest that we have right now that has the C12 within it. But as Kel mentioned before, our entire robotic line is right there within the simulator, right? This is very good for you guys that are working from home right now who do not know when you have access to the robot, or you have a design in your head and you want to know what that cycle time would be, or you want to play around with different styles. Will this work with a C4? Can I get away with a C8? Maybe I need the C12 because of that reach. You have the options to play around with to run the simulations so that by the time you're actually back in your facility, after you run the simulation, you'll know what product you need and you'll know exactly what that cycle time should be, and you can move forward with the right robot for that application.
Right. One thing I want to ask our audience, if you would send me a message if you're interested in this. We're not going to be going into the simulator today, but I would be interested in scheduling a webinar to show how to run the simulator, how to set up a robot, how to synchronize the clock to get accurate cycle time measurements coming out of it. If anybody's interested in learning more about the simulator, how to make it run, and how to be able to do some feasibility studies with it, if you would shoot me a message in the chat room, I'm going to be monitoring that, and I'll use that to decide if that's going to be a future webinar topic that we will bring to our customers. So let's talk about options right quick. And Casey, these options aren't limited just to the C12. These are available throughout the robot platform. Things like the integrated vision and the new IntelliFlex part feeders, different field bus options, as well as the force feedback. And there's more options that are available than just what's listed here, but this is available for almost the entire range, just depending on the individual robot performance and capability. But it's not just a C12 option list.
That's correct. That's correct. And I think sometimes we need to throw it out there because people look at robot models and then just don't understand how we try to make the whole integrated package very easy at the end of the day. With the IntelliFlex, I mean, that's parts feeding, right? You can flip parts. You can figure out what the right parts assembly you are. So that flex feeding system is very, very crucial. And the way we made it, and that could be a whole nother webinar in itself. So I won't go into big detail, but I'll just say, if you've worked with other feeders before, this is a very simple process in order to there's a very simple process to work for parts feeding, and the way we've integrated into our software is second to none. I mean, anybody can get it up and running very quickly. So flex feeding, T-spin it, field bus options, whichever way you want to communicate, CC-Link, EtherCAT, DeviceNet, ProFeedNet, ProFeedBus, Ethernet IP. We have the COM styles. And then we talked about injection molding, Euromap 67. I mean, T-spinners, so many different options where you can choose from. But just a quick reminder that it does work with the C12 as well as our entire product line.
Good deal. All right. I'm not going to spend a great deal of time on this page, but there's one thing I did want to point out, and this really impressed me, that we're dealing with a robot. If I look right here at the weight of the robot from the C8, 8-kilogram payload, to the C12, the weight of the robot itself only goes up 1 kilogram according to the spec sheet here, but we're keeping the same repeatability at 50 microns. So I thought that was impressive to be able to gain that extra performance out of the unit without drastically increasing the weight or the overall size of the base or the bolt pattern that we have to have for it. I thought that was quite dramatic.
I agree. I mean, you're not sacrificing on anything, and you do get more payload. So you're absolutely right.
Okay. So real quick, this does come up for machine builders and whatnot. Now these are, just raw robots themselves, but it's a very reasonable price point to be able to get started within this realm for this payload. So that was one of the things I did want to mention. But this is just the raw robot. You're not going to get that with a program ready to run. There's still development work that needs to be done with it.
But before you move on, I think we probably need to point out that price actually includes controller and cables, right? Sometimes some guys may think that there's additional cost for a cable, additional cost for a controller. No, this is the price. You get the robot arm, you get the controller, and you get the necessary cables to move forward. So this is a great price for clean room and standard.
Good deal.
And simulation.
And simulation.
And the simulation, the 3D simulator. And one of the things I forgot to mention while we were on that slide was the Epson simulator allows you to bring in a full step file of the machine that you're going to put it in, import it into the environment, and you're able to attach your end of arm tooling step file to the tool flange or the quill of your robot. So now you can test the unit out as if it's already built into your machine before you cut the first piece of metal with it, to make sure that you're going to clear, hit your cycle time, and have the reach necessary. All right, let's go into our next update. So the LSB series, this is an improvement on your existing LS. And the LS was already a great mid-performance level SCARA, but you've got some new features that are coming out within this series that really adds to it. And one of the things I noticed right here was the fact that you're adding the clean room models now available into the LS series.
That's correct. I mean, the LS is getting an overhaul. I think if you look at Epson and you look at the way we promoted our products, especially over the last 2 or 3 years, we've gone all out promoting our all-in-one T series that we have and our VT6L that just came out a year ago. But as I mentioned before, over 400 different models. So we have the LS series, the G series, and we're actively in the process of overhauling that as well. So our LS is getting a full overhaul, a full makeover. We came out with the LS6 and the LS10. So the LS3 and the LS20 are the ones that we're coming out with now, just to round out that full product line. And as Kel mentioned, ISO 4 is right there. A lot of other cool designs that you guys will see as we move forward within the slides, but you don't sacrifice on performance. Actually, the performance kicks up a notch with this new overhaul. So I think you'll be pleasantly surprised if you guys have used the LS before.
Yep. And as Michael said earlier, the LS series with the QMEM technology has been there since the beginning, and that's still there. So we still have that ability for that more precise control and decreased settling time within the entire family. One of the things I did want to showcase, an actual LS in action. So this is an LS3. So this is running, happens to be at the same contact lens manufacturer that I had referenced earlier. These are the vials that would go to the end patient. So there's a jar of saline solution here, and there's a cap with a holder for the custom prescription lens to go into. And they had a person that was sitting here at their station, and their entire job was just to dispense saline solution in these bottles. And they would sit there 6 hours a day, every day of the week, doing nothing but get these bottles prepped for the contact lenses to go in. And this is an application that we were able to put an LS into, to be able to automatically pull the caps off, be able to fill with the saline solution, and be able to allow them to repurpose that operator to a different task that required more of the human interaction. And now this just fills the bottles and off they go, and has been running very well for them. All right, so as Casey alluded to, within the LS family, so we start LS3, 3 kilogram payload unit, LS6, you may pick up a pattern here, 6 kg, the LS10 for your 10 kg, and the LS20 for the 20 kg. And rounding out the line, we now cover a nice range of this on the mid-performance unit. And as we said earlier, we've got the QMEM that's there, so we have the better control. But a couple new things that I saw with this series that really stood out to me was the fact that you've gone with absolute encoders. So we no longer need to have batteries, and we no longer need to have in our maintenance schedule to change the batteries out in the robots. I would refer to this as the January 2nd phone call. Oh, we shut down the robot over the holidays and we went to turn it back on and we're getting an error message. Well, the rechargeable batteries went bad and they didn't get replaced, and now we're UPS readying them in. That problem's now been eliminated, hasn't it, Casey?
Absolutely. I was going to say that's very important, because if you experience a shutdown, robots on the shelf, whatever the case may be, you don't have to worry about losing your information. It's still there.
No, absolutely. I'm going to go to this next slide to point this one out. This one I really, really liked. Just like you've done with the C8, just like you've done with the C12, you're now incorporating that RJ45 camera port right into the top of joint 2. So instead of having to pull the camera cable all the way back and be able to secure it and worry about it getting snagged or coming loose, or that extra thing that has been added and routed, now everything is just right through the duct, and you're able to put that right onto the top of joint 2. That's a huge improvement for anyone who's ever worked with mobile mounted vision before.
Yeah, I mean, you're right. To have that that port right there, but also the additional screw holes for mounting, right? So we want to make sure as we move forward, or at least you'll see a pattern here, easier for you to put your tooling on our robots. And I think that's where we're going with this overhaul, just to make it a cleaner look for you guys, to help reduce your cable routing and wiring that you would have. So this this helps you out tremendously. If you've ever been frustrated about mounting cameras on robots before, this is you'll find quite joy in this slide. This is good.
Absolutely. Like also on the LS20, just like we were talking about, the added LAN port for the camera communications, the pneumatic line pass through, the electrical line pass through, and the extra mounting holes to be able to put your valve manifolds, sensor amplifiers, whatever it is that you're needing to put closer to your end of arm tooling, you've got additional hard mounts to be able to take advantage of for that design. This one I liked as well. So the older LS3, the ducting went above the height of the quill, which meant if I needed to put this in a design, I not only had to take into account the height of the quill, I also had to account for the ducting height as well. That's been lowered to where now all of the ducts do not go past the height of the quill in design to allow for a more efficient use of space. Has this been a positive feedback from everybody so far?
Oh, absolutely. People love it. I mean, because the last thing you want to worry about when designing a cell is the cable, right? The cable routing. I have to make sure I accommodate for that extra, 130 millimeters of cable routing that's there. So knowing what your quill size is, knowing the height of that, knowing that you can design to that and place it within the cell is huge. It's no more gadgets.
Okay, good deal. And then, of course, the clean room. We've not had a clean room in the LS series before. So being able to fit the ISO 4 clean room, obviously with a SCARA, the protective bellows to be able to keep the particulates from getting into the air, as well as the vacuum port to be able to remove any wear particulates out of the robot to make sure that your environment remains clean and protected. This is a new option we've not had in this series before. But there's one of the things, Casey, I think is important to point out. Historically, with Epson, when you purchased a robot that was clean room, it was also ESD rated. In this case, this isn't the case. So we can't just fall in fact, when we were doing our dry run yesterday in preparation, I made the statement of clean room and ESD, and Casey had to correct me that in this case, this is not ESD compliant. So if you are a machine builder or integrator that's listening to this webinar, please keep that in mind that in this particular case, you don't automatically get the ESD with a clean room in the LS series.
That's correct.
Okay. We also have a new controller for this one, Casey. Historically, the RC90, I had to order it up front either as a PNP or NPN. Am I reading this right, that now I only have one model and I can wire it either way?
That is correct, right? So the 90B controller supports both PNP and NPN wiring, which is very huge. As you know, or customers learn, this is a big deal. A lot of our other controllers support both wirings, and it's very good to have the LS controller now support both wiring as well. It makes ordering so much easier for you guys, and now you only have one particular model that you can keep on your floor. So you don't have to keep a PNP controller or NPN for this particular one. You can have one controller that supports both wiring, and it's better for everyone.
Yeah. One of the things that I really like that Epson has done when the RC90 first came out and the RC700 came out is the attention to detail to make sure that all of the maintenance interface is all on the one plane. The filters, the batteries, the electrical hookups, the connections are all on the front face. So when this goes to get deployed in the field, it goes to get mounted into an enclosure, there's only one face that you have to plan for access to. You don't have to get to the other surfaces for any of the maintenance portion of it.
Yeah, I was gonna say, this might not be a big deal for engineers, but if you're a maintenance guy, you don't want to dig in a cabinet longer than you have to, right? So this is right in front of you. This is a good thing, a very good thing.
Yeah. Now we talked about this earlier. The integrated vision, the IntelliFlex feeders, the various teach pendants, the various field bus protocols, we still got a nice list of options that we can use within the LS series. And this would be the same IntelliFlex feeder that we can use on the LS, or the same vision on the LS that we would use with the C12. Again, that commonality of all of the different components and accessories working with each other.
That is correct. So there are some options that work across the entire product line, but then the LS are limited in some others. So like that TP3 pendant that you saw within the C8 series would not work with the LS here. Or we were actually just talking about this yesterday, Force Guy. So there are some options that do not apply to the LS. So I just think you really want to have a conversation with ACS and with myself to make sure we can get you the right accessories that you would need for your particular product line, for your particular project, so we can make sure we can say, hey, the LS or really the G or whatever the case you may need, we'll get you in the right robot.
Yep. Okay. I did want to highlight just one more time. We've talked about different SCARAs. I mentioned the G series in my story a little earlier. We've talked about the LS. The T series, we don't want to forget about. That's an incredible platform. So this kind of goes hand in hand with what you were just saying, Casey. The T series, the all-in-one, the Synthesis series, where the controller is built into the base. Price point on that starts well below the $10,000 price for a full robot. So the ability to have that one small basic pick and place system, but of course the controller for that being built in, just like Casey was alluding to, isn't compatible with all of the higher end options. Also, the speed's a little slower on that one because of the wattage motors that are in, but if you're doing a basic pick and place, it's a great option. The LS series, mid-range, mid-performance, it's faster than the T, not completely full open to all the options, but it's also a more mid-price point. And then the G series, man, the 24/7 run at 100%, put anything option on it that you want to, run multiple robots off the one controller. It really is a phenomenal workhorse platform for those applications that really demand that high intensity uptime. So with today's conversation being focused around the new products, the LSB series is the new one. However, upcoming, there will be a webinar that we're going to be doing on the Synthesis talking about the T series. We'll also talk about the G series in a future event to show its power and capability. But just real quick, if for our audience members that might have an application they want us to look at, send us parts for evaluation, we may recommend one series over the next. So one thing I did want to point out, just a couple of the differences. When we talk about the T series, the controllers built in, lower cost, basic system, LS3 for a mid-range performance unit, the G series for our full performance unit. I did want to, oops, click the wrong one. I did just want to highlight a real quick speed test between them. They've all got the same, quality, the same RC+7 software environment to be able to work with, but there is a performance difference between the robots so that they can be tailored. In case you alluded to this earlier in our discussion this morning, so they're tailored for either a lower cost, more basic application, or that full featured high demand 24/7 output that you've got to get through with a faster cycle time. So just real quick, Casey, how does having these different platforms that are all SCARAs, in this case, they're all a similar reach, they're all the same payload, what does this provide Epson over some other folks in the marketplace to take care of your customer base?
Well, I think it gives us more depth into the market, and then more ability to actually look at your application and figure out what do you need and what are you looking for. Because some people's speed and might be the bigger issue. Other people, you might have that time needed to do that assembly work, right? So when you look at cycle time or you look at performance, you may not need the workhorse, the G, right? So why would you want to pay that money if you can get it done with the T series or with the LS? So I think this is where we say we are not just precision specialists, but we are really consultants. We want to talk to you, figure out what your goals are, what you're trying to do with your particular project, and then based on your goals and what you want to do, we can say, hey, this is the right recommended series for you. And then of course, we will run the simulations with you, we'll walk you through it, and we'll get you right there. I mean, I would say once we have a simulation, once we understand what you're trying to do, I don't want to say 100% of the time, so I'll say 99.98% of the time, we will get you where you need to be. Is that pretty fair, Kale?
I think that's great. And one of the other things I wanted to point out with the simulation software, I make this as a regular habit. When someone does send me their specifications they want me to do a cycle time study for, within the simulator, I can pull up my T series, I can pull up my LS, I can pull up my G, and I can let my customer know here are the cycle time differences between them and what we're able to achieve, so that before anything gets bought, anything gets designed, anything gets cut metal for a stand or anything else, they already have a very good realistic idea of what they can expect performance-wise out of the system. And the software makes it very easy to get that set up and accomplished within the simulated environment. All right, our last thing that we're going to get into this morning is the updates to the VT6L. So the VT6L was released, has it been 2 years now, Casey? Or is it just last year?
Just last year, right? A year and a half. Is that fair?
About a year and a half, yeah. I think so. Great product, phenomenal product for its price point, for a 900 millimeter arm that is a 6 kg payload, is just incredible. Controller built into the base. This is part of the T series family. So this is part of the Synthesis series robots. 110 volt AC power, so no transformers, nothing special. No extra controller to mount, everything's built in all in one. And now that's being extended to include the clean room and also now an IP67 washdown version. So this is going to be a new area for this.
It is. And this is what customers have been asking for us, which is, hey, you know, the VT is nice, but if I had a clean room version, that'd be awesome. Or, you know, if I had a IP67 version that I could do washdown, that'd be great. So we've heard you, we understood, and we started designing towards it. So now what you have is this clean room ISO 4 that just came out, and then in a couple of more months, we'll have the IP67 version that's on its way.
Okay, but these are available to work with within the simulator. We can get CAD drawings today if we wanted to go ahead and start looking at it for an application.
You absolutely can.
All right. One of the other things I thought was unique is in the tool flange, it is a hollow flange, allowing for pneumatic lines or cables to go right up through the center of it. So if I'm designing my end of arm tooling, rather than having to come around with a loop of line that could potentially get snagged or hooked on something, I can go right up the center of it and be able to just clean up my wiring package. I thought was a very unique design that y'all introduced on this one.
Yeah, it's very different and very good. I mean, overall, you will have to wrap your cables around towards the, you know, from your base up around. But you're right. As you get ready to connect to your inner arm tool, you can go right through the center. So it is a very neat design.
All right. The other thing, now this is true with really all of the T series, but specifically with the VT6L that we're talking about, since there's not a separate controller that is built into the base, I don't need an electrical cabinet, I don't need an air conditioner, I don't have to worry about those type of accessories. Or if I do have an electrical enclosure on the machine, I don't have to oversize it to accommodate the robot controller. It only has to be for my other equipment that are on the design. So I thought this was a nice point because it lowers the overall cost of the machine build by smaller cabinet, lower cost, less wiring that has to go along with it.
It does. Everything you need to control that VT6L is right there in the base of the robot.
Yeah. This is one of the ones that's amazing to me. I mean, we already knew this from the last year and a half. VT6L, full 6-axis robot, 6 kg, 900 millimeter reach for under 14 grand. That is a very significant price point, but now I can upgrade to a full IP67 washdown below 16 grand. That's an amazing price point for, again, there are no cables that you have to buy. The controller is already built into the base, so it's the equivalent of controllers, cables, and all at that price point. You're ready to put it on a stand and put your tooling on it and begin production.
Yeah, you're absolutely right. I think people were impressed when we put together the VT at 13. And, you know, once again, we're not here to gouge people. We really want to make this very affordable for you. So we're giving you the clean room. We're giving you the IP67 version, less than $16,000. Absolutely amazing.
All right. One of the things I do want to point out, we did purchase a VT6L for our demo inventory. It has already shipped from Epson. It is due to arrive at our facility next Tuesday, May the 19th. So from that point on, we will have a VT6L that we can do live work with. So we can schedule an additional training webinar. We could interact with right now while we're in the shelter in place. Obviously, we set up a video conference, but we could also, in addition to the simulated cycle time study, which is, you know, generally as good as maybe plus or minus 15%, we could actually hook up a live robot and actually get a more real world cycle time study if needed. Just to make our customers aware, we do have in our demo pool a T3, a T6, and an LS3. So that gives us 4 Epson robots within our local demo pool in the Southeast to be able to perform those live studies with. So if you're attending in our audience today and you have parts that you would like to test, you've got a application you would like us to do some feasibility on, send us the parts, send us the details. We would love to be able to work on that with you. And that kind of sums up where we're at. So our general email box, info@acs-ga.com. That is where you can email us to request information, to request additional copies of software, CAD drawings, arrange to send parts into us. Also, EpsonRobots.com, great website. The CAD drawings are there, the option lists are there, the capabilities, the full list of accessories is all online. Epson's done a great job with that website. Casey, Michael, I'm going to let you offer your closing comments. I'm going to take a look at the chat room. If anybody has got a question or something they would like to expand on, please post that in the chat room. I'm going to be looking at it while Casey and Michael put their final thoughts on things, and then we'll close out.
Yeah, so real quick, and I'll let Michael go last because I report to him. He's my boss. But I just want to say,
Oh, that's a lot.
We definitely thank you for your time. This has been fun. I work with ACS very closely. They are our top distributor in all of our company. These guys are very good, very technical, and we really want to talk to you about all of your applications that you have, all of your needs. With me being in Charleston, South Carolina, me being in Georgia and Tennessee, virtually at least once a month, we would love to sit down and just talk to you and see what you're trying to do. So we thank you for your time. We thank you for your interest in Epson. Whatever we can do to help you moving forward, definitely please feel free to reach out to both of us. Thank you.
Thanks, guys, for all the time. We really appreciate it this morning. You taking time out of what we know is a very valuable for you. The one thing I would like to say, and Casey and Cale both put it pretty well, we want to be able to develop the robot that will fit your application. And rather than you having to design the application around the robot, whatever your application need is, we want to be able to have that robot available for you. So that may be a simple pick and place operation where a T3 at a lower cost will work better for you, or an LS in the mid-range, and then a G series when you get into some very complex applications. The whole point is that we want to sell you the right robot for the application. We're in here for the long term. So no matter what it is, we know that once we're able to prove to you that it works and you get the support that you need and the other things that you need, that over time you will come back to Epson to help you solve your problems again. So we very much appreciate everybody's time. And if there's any questions at all, we'd be happy to answer those. Okay. So thank you again for attending.
All right. Well, the haven't been any questions been posted, so I think we either put them to sleep or we answered everything through the presentation already, guys. I did get a couple of feedbacks from folks asking about a webinar for the simulator and how to make it run. So that is something I will look on putting on the schedule in June, and would love to have you guys, join us if you would like to for that one. Want to thank you for your time, Casey, for being online, and Michael, I really appreciate you being available to let me put you on the spot, totally unexpected to present this morning.
Yeah, no worries. Good seeing you again, Cale.
All right, thanks everybody for attending. A copy of this is being recorded and will get posted on our on-demand webinar section. So if there's someone at your facility that could benefit from our discussion to be made aware of what's coming up from Epson, you can be able to direct them for that. I will be adding it to my LinkedIn post with the link to get to the on-demand here within the next day or two. Thank you everybody for attending, and I hope everyone has a great day.
Thank you, sir.
Thanks.